Well, hey guys, Mr. Roden here. How are you doing? You can see, if you can see behind me, this is my room. It's Friday, and I'm getting the lesson done today. I'm not at home on Sunday night doing the lesson, so that's good. So thinking ahead a little bit. So today, what we're going to do is some pretty good stuff. Some actually pretty big geometry stuff, actually. So pay attention to this lesson. I'm going to throw a lot of good stuff at you here. All right. So learning target. I can prove figures and their parts are congruent using CPCTC. Say that 5 times fast. CPCTC, 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 CPCTC. But you can't do it. All right. I can do it because I've said it so many times over the years. So we'll see what this whole CPCTC thing is, or CPCTC if you say it a little slower. All right. Good thing. My good thing is, guys, I'm thinking ahead. I'm getting my lesson done for Friday, so that will give me a little extra time on the weekend. Usually my lesson takes about an hour to get done, and so I'm getting it done during school today because I have a little extra time. I'm not my day opened up a little bit. I wasn't as busy with my other school stuff today. Homework bucket. All right, let's take a look at the homework bucket, shall we? All right. I'm actually not going to take a look at it, but I just want to mention one thing. In the homework bucket, guys, the quiz. So we'll take a look at the quiz. I'm going to put the quiz in on Monday. So when you view this, probably look over to Q and look at your quiz. I want to thank Alden because Alden showed me one where it won't be because everyone's numbers are different, but the one where you had to rotate 270 and then there was a vector that you had to also translate. It actually was quadrant 3. And if you missed that, I will just give you that point. I'm just going to manually go through and give you those points. So that was one that I had actually marked quadrant 4, I believe, and it was actually supposed to be quadrant 3. So just know that if you missed that problem where you had to rotate 270 and then translate, it would the answer. If you got 3 on that, then you're good. I'll give you that point, and I'll put it in Q. So it should reflect it in Q. So it won't, even though in Schoology it kind of says it's wrong, I'm going to fix it and put it in Q. So don't stress too much. All right, cool. So let's take a look at the warm-up today. Warm-up, what I like to do on warm-ups is I want to go ahead and do a construction. And I want to show you kind of a cool construction. It's a really easy construction. And then I know Alden and Noah, I believe, want to do a presentation for some extra credit, and I haven't had a chance to get them to do it. So here's your chance, guys. Tomorrow, when we have class at the beginning of the warm-up, if you want to present this, great. Or if you don't, then we'll just call it good, and you can find another chance to do it whenever. But tomorrow is the time. I'm going to let Noah and Jonah do their presentations if they want. So this is what I want them to do their presentation on. This is what I want everyone to do their presentation on. So let me go to the geometry tools really quick. All right. So what this is going to be is we're going to be bisecting. Let me say this again. Constructing a perpendicular bisector. Okay. Now, what does it mean to be perpendicular? Perpendicular means when two lines cross, they're going to cross at a 90-degree angle. Okay, so if I have two lines that are perpendicular to each other, so if I have this line here, okay, and let me change the color here. Let's say we have this line here, and they cross. These two lines are perpendicular to each other if they are 90 degrees. This angle right here, where they cross, is going to be a right angle. And this is how we show, obviously, right angles, just a little box like that. And then all these angles here, all these angles are going to be right angles. This is going to be a right angle. I'm going to make it a little bigger just to kind of show that this is going to be a right angle. Like, get the box a little bit. That's a right angle. This is a right angle. This is a right angle. Those are bad right angles. And this is a right angle. And why am I making them so huge? I don't know. But those are all squaring. They're all 90-degree angles, right? Okay, so let me clear this out. Now, what is a bisector? Well, if we have a line that bisects another line, okay, so let's say I have just a segment or a line, and I have another line coming through it, and let's say, let me just put some points on the end of this line. So let's say that this is, let's say that this is segment AB, okay? Say this is segment AB, and I want to go ahead and bisect this segment AB with another line. Let's say, let's go to a blue line here. Get rid of compass, and let's say we want to take this blue line and we want to bisect it through AB. So if this is a blue line, if this blue line bisects AB, so this is going to be, draw this down here. This is going to be, pen needs to be working here. Okay, so if this is going to be A right here, and this is going to be B, and let's say this line, this is a line, we'll say, and this is, we'll call this line L. If L bisects segment AB at, we'll say, at point C, right? Then let's call this point C right here. If line L bisects segment AB at point C, then I'm going to know that, and this is how we're going to mark it, that AC is going to be congruent to CB. So if this truly is a bisector, this blue line right here, by definition of a bisector, that tells me that AC is going to be congruent to BC. Now remember, we're not talking about equality here, which we're talking about because we're not measuring anything with a ruler. We're talking about congruence. I could cut one and put the other one on top of it. That's kind of how I like to think. And here's how we like to mark congruence, okay? This is a symbol. We just put a slash through it. So we could say that these two are congruent, and you just learned something here, some notation here. AC is congruent to BC, and I can say that by putting these little congruent slash marks through it, okay? Now, let's put this whole thing together and let's construct a perpendicular bisector. So remember, we just talked about perpendicular, which means it's 90-degree angles, and we talked about bisector, which splits the segment into two congruent parts. So let's go ahead and construct one, a perpendicular bisector is what we're doing here. So let me construct a segment here. I don't need that. Let me get rid of that. Okay, and I'm just going to construct this segment right here, and I'm going to call this segment, pull up my compass. We'll keep it really simple. We're going to call this segment AB, okay? We're going to call this segment AB. All right, hopefully I've got enough room here. If not, I might have to change the size of this a little bit, but we'll see. Okay, so we're going to call this segment AB. So let me write that down. This is segment AB. This is A. This is B. I've decided if you don't lift the pen up, you can make a much better letter. I've decided so. Okay, so what we're going to do is we're going to construct a perpendicular bisector here. All right, so what do? Well, the first thing we do is we take our compass, we pull it up, and I'm going to go ahead and change the color on this just because I think it will see it a little better. And then I'm going to take that compass and I'm going to stretch it over halfway, okay, on the segment. So I'm going to start on I'm going to put my needle on A or B, it doesn't matter. And then I'm going to take the compass, I'm going to just stretch it over halfway, okay? So, and you just eyeball it, okay? Obviously, that's over halfway. Obviously, this is under halfway. So just eyeball it. It doesn't have to be exactly halfway. It just has to be bigger than halfway. So do you guys agree that this looks over halfway? I think it does. And then what you want to do is you just want to take an arc here, and let me lock the compass. And now we want to take this arc. Now, hopefully, I think I'm going to have enough room here. It's going to be close. Okay, I'm going to clear this out. I got to make this a little smaller because you're not going to be able to see something. So sorry about that. I'm going to make this a little bit smaller, all right? So let me clear this out. And all I'm going to do is I'm just going to make a smaller segment. And the reason why is it's just it doesn't show up on the screen if I don't make a smaller segment. So let me just do it like this. Here's a smaller segment. And then we'll come over here. And then we'll put a mark on it. That'll be my A. And that'll be my B. Really apologize about that, guys. Okay, and then let me go do this. I'll move this off to the side for a second. And so this is going to be AB. I knew that was going to happen. I just was trying to get lucky and not have to make my new one. But okay, the reason I had to make a smaller segment is I'm not going to be able to see my arcs if I do it like that. Okay, so hopefully this works better now. So now I'm going to come over here. I'm going to grab my compass. I'm going to put the needle on A, just like I said. I'll change the color just so you can see a little better. Then I'm going to unlock my compass. Okay, and then I'm going to bring it down. Remember, I only want it over halfway. And that looks pretty good right there. That looks over halfway. So I'm going to lock my compass. Now I'm going to make an arc. I'm going to make an arc up here. Good, that's much better. Now I'm going to make about half a circle. Okay, half a circle. All right, good. Now what I'm going to do is I'm going to take my compass now, and it's still locked, and then I'm going to shift it over here, okay? And now I'm going to make it like that. There we go. And then now I'm going to make another arc. No, notice it's the same setting as when the compass is locked, so it's the same setting here. And now I'm going to make another arc like that. See that? And so what I do is I have these two kind of opposite arcs that intersect each other here. All right? And so remember, we always have to open it up over halfway. So now I can get rid of my compass, and I get 2 points where these two arcs intersect. So I'll do put the black letters up here, get rid of the compass, don't need that. I just need the pen. So let's call this CD. Okay, so we'll call this C right here, and we'll call this D down here. Okay? And so what we'll do is we'll construct a segment that goes through both of those points, okay? We're just going to construct a segment going through both of those points. You could use a straight edge. I just use the line maker tool on here because it's so much easier. And I'll make it green. Okay? I'll make it green. Don't need that compass. So I'm just going to make a green. I'm going to get a segment that goes right through those 2 points. I got to make sure it goes right through it perfectly. And this is where it gets a little challenging. Perfect. All right. So what have I done here? I've constructed a segment that this now is this green line right here is a perpendicular bisector. So what do I now know? Well, I know, ladies and gentlemen, that these angles, and I'm not going to put all the right angle symbols in, but I know that this is going to be a right angle symbol right here. These are all right angles. And I've also know that, and we'll call this point right here, point, get black here because we did black. We'll make this point E right here. Okay, this is point E. This is point E right here. And so what I can now say is I can say that segment AE and segment AE is congruent, terrible, right? This tool is crazy, to segment EB. Oh, that's pretty good. Those are congruent to each other. And what I can do is I can put those congruent marks here. All right. So what I've done is I've constructed a perpendicular bisector. Now, you could always measure. Remember, if two things are congruent, then they have equal measures. Okay. So if I kind of take this and let me see if I can rotate this up a little bit. And I'm just not going to do too picky here, but that's about what? Almost 3, right? And this one is almost 3 also. So yeah, so perfect. Perpendicular bisector. So so tomorrow on our warm-up today, everyone's going to construct perpendicular bisectors. It should be very simple, but Jonah and Alden are my 2 kids, I believe, that I owe a chance to create one in front of the whole class for some extra credit. Sound good? Awesome. All right, let's get to our lesson here for today then. So that's our warm-up for today. And so now our lesson is going to be 3.1. Okay, so let me go ahead. I'm going to pause this because I haven't copied all my stuff into here yet. Let me go back here and pause my video, and let me copy and paste all the stuff I got for you. Okay, guys, sorry about that, but let's go to now. I just put it in there. Okay, so here's the first thing I want you to write down. Corresponding parts of congruent figures are congruent. And if you take the first letter of, let me draw this, you will see at the beginning of this video, I said CPCTC very fast. Well, where did I get this whole CPCTC thing? CPCTC. Corresponding parts of congruent triangles. And so this one is CPCFC, but really a lot of the time, guys, this figure, I'm just telling you right now, is going to be triangles. Okay, so I'm going to tell you right now that our figures that we're going to focus on are triangles, mainly for now. So we're going to do some non-triangle stuff at the beginning, and then it's just going to go all the triangles, okay? So the reason it's not CPCFC is because CPCTC, T stands for triangles, Right now, we're going to look at figures, but as we move on shortly, all our figures are going to be triangles because triangles are the basic unit of polygons, right? It's the smallest sided polygon. So if we can prove things for triangles, we can prove a lot of things for more complicated figures like quadrilaterals and pentagons and things like that. Okay? So it's F for now, but it's going to shift to T. So that's why I'm so used to saying CPC, TC. All right, so copy this down. If two figures, so pause me now and copy this. This is huge stuff. You need to know. We're going to be using this all the time. So I expect you guys to have this down and know what it means. Okay, so CPC, FC today, but TC from now on. Two figures are congruent. If two figures are congruent, then their corresponding sides are congruent and their corresponding angles are congruent. Okay, and that's a pretty simple concept. This is like I would call this a postulate. Okay, it's just there's not a provable fact, but if you know you have two congruent figures, then all their corresponding parts are going to be congruent. Okay, so let's take a look and see. If we look at this example right here, and the hardest part of these problems, guys, is figuring out, especially if they've been rotated or reflected, it's sometimes hard for me at least to picture where the corresponding parts are. Okay, so let's see here. Well, this one, so what I like to do before I kind of start to, let me just kind of get rid of these because these numbers don't really mean anything. So before I start kind of getting, start listing the corresponding parts out, what I want to do is I want to just kind of match everything up. So if these two triangles are congruent, if this is 43 feet from U to V to X, then this has to be 43 feet. See that? And if this is 32 feet here, then this has to be 32 feet right here because they're congruent. Their parts are going to be congruent. We're using CPCTC to list them all out. Okay, now here's the thing. We got to be really careful. So if this is an 18-degree angle here, I believe that 18 angle is going to be right here on this triangle. And if this is 38 here, this is going to be 38 here. So what we can do is, and I don't even want to do any of this stuff. When we have triangles, I want to list just all the corresponding parts out, okay? So what I have is, let me just start on the left triangle. I have three angles and three sets of angles, and I have three sets of sides that all are going to be congruent to each other because of CPCTC, because the two triangles are congruent. And we know they're congruent because it's given right here. And that's an important thing. If we're not given that they're congruent, then we can't do it. Okay. All right. So let's see here. So let's first of all, so we have angles. So we have the measure of angle S. I'm just using the left triangle. We have the measure of angle U, and we have the measure of angle T. Okay. So now, what does angle S correspond to? Well, angle S corresponds to angle V. So we know that the measure of angle S is congruent to or is equal to the measure of angle V. And the reason I'm using equality now, because I'm talking about measures. I'm actually looking at the degrees. Someone put a protractor on these things and measured them for us. Okay. All right. So the measure of angle U is 18 degrees. So what has to be what is that equal to? Its measure is the measure of angle X. Okay. 18 and 18. And then the measure of angle T is 124. So we know the measure of angle, and forgot to put that in there, angle W is 124. So the measure of angle W is equal to 124. You guys see that? So remember, M stands for measure. Now, let's talk sides for a second. I'll change the color to blue. So let me just use the first side. Now I'm going to use the measure. Now, if I'm not going to talk about, I'm going to say US, and I'm not going to put a line over it because I'm not talking about the segment itself. I'm talking about its measure. So what is the measure of US? It's 43, right? So, but what is it equal to? Its measure is equal to VX. And I'm not going to put a line over it because no line means measure. If I put a line over it, that means segments. Segments are not equal to each other. Segments can be congruent to each other. They're not equal to each other. We're talking measures here in this case. All right, so now what's the next one? We have a 16, that's ST. So we have ST, its measure is 16, no line over it because we're talking measure. And so what would that be? Well, yeah, it would be over here. It'd be, that's the 16 there. I didn't write that in yet. So 16 here, it's got to be 16 here. So that's going to be WV. Okay, and then what's the last one we haven't used yet? I believe we have not used, what yet? We have not used, we've used US, we've got that one. We've used ST, so we need to use UT, right? So we have UT, which we know its measure is 32, and that's going to tell us that WX is also going to have an equal measure because it's also 32. And so what we've done is we've listed on a triangle, you get 6 different pairs of congruent parts. On rectangles, you get 8, right? On quadrilaterals, you get 8. So we have 3 pairs of angles and 3 pairs of sides. Corresponding parts are congruent. All right, that's CPCTC for us. All right, now here's a couple properties that I want you to copy them down and copy them down carefully because they're important. And I will tell, so we've got the reflexive property of congruence. It's a huge property and it's so simple. All it means is AB is congruent to AB. Okay, so if you have, and when would we use that? So if we have a triangle with a middle down the road here, down the middle here, and if this is AB and this is AB, this side right here, AB is congruent to itself, right? If this is C and this is D, and we have a triangle with, we kind of have 3 different triangles. We have the big one, and then we have the 2 small ones here. So this line right here, AB, is congruent to AB. It's congruent to itself, and we'll use that a ton. Symmetric property, AB is CD, CD is AB, right? So we know if we know that we can say this. If we're looking at this picture right here, if I know that CB is congruent to B, because we're talking about congruence, I'll put line BD, then I can just flip it. I can just say, okay, well then BD, and this one is congruent to BD is congruent to CB, right? So pretty simple stuff, a lot like the algebra properties, right? And then we have the transitive property. If AB is congruent to CD and CD is congruent to EF, then we can skip the middleman and just say that AB is congruent to EF. Okay, same stuff that we've been doing in algebra, except we're using congruence here and not equality. Okay, all right, so let's take a look at this. Okay, these 2 quadrilateral GHKJ is congruent to quadrilateral LM and P. Find the given sides or length of the measure. Okay, so what I want you to do now is I want you to go ahead and pause the video. I'm going to pause also, and I want you to find, let's do this. Let's find LM and measure of angle H. So go ahead and do that right now. I'll pause the video, and then I'll have the answers for us at that time. Okay. Make sure you pause that video and give these a try. Okay. Don't just wait for me to do it for you. So see if you can give this a try and see if you can get it right. Okay. So did you pause it? All right. Okay. So let's take a look and see how you did. All right, so I'm going to look at the blue writing here. So the first thing that I did is I highlighted the corresponding parts. And remember, CPC-TC says that the corresponding parts of figures are congruent. So if I notice, I just highlighted, I noticed that GH, it looks like one could be, if I rotate counterclockwise, I think probably 90 degrees would get me there. I can see that this side and this side are corresponding sides, right? And it's kind of hard to see sometimes, so hopefully I did that right. So the yellow sides are corresponding and the green angles are corresponding if I do that. So I'm saying that H is corresponding to M and side GH is corresponding to LM. So I can set them equal to each other because if the corresponding sides are congruent, sides are equal. I do the math. What did I do here? I subtracted 4x from both sides, and then I added 13 to both sides. I get 16 equals 2x, and then divided by 2, and I get 8. Hopefully my algebra is correct. So I get x equals 8. This one, I set up the equation that put the two green equations equal to each other because they're corresponding angles. I have 9y plus 17 equals 11y minus 1. And then I have 17 equals 2y minus 1 because what did I do? I subtracted 9y from both sides. 11 minus 9 is 2. And then I added 1 to both sides to get rid of the minus 1, so that gives me 18. And then I divided by 2, and I got y equals 9. Okay? And then, but see, what they wanted me here is they wanted to figure out, well, what is LM? Well, LM is equal to the expression, LM is 6x minus 13, right? So I put that in, and then now I know that x equals 8 from my previous work. So 6 times 8 minus 13 is 35. And then how did I find the measure of angle H, what they wanted me to do? Don't worry about these numbers here. They're from the examples that I snipped from the book. I have the measure of angle H equals 10y, okay? Because I know that H and L, the measure of angle H. 1 second, let me just make sure I did that right. 1 second. Sorry about that, guys. The measure of angle H is actually equal to the expression 9y plus 17. And then I just plug a 9 in for y. So I get 81 plus 17 gives me 98. And I am done. How'd you do? Pretty good? All right, let's do another example here. All right, here's a good one. Now, let me just talk us through it. This is called a proof, okay? So, but this proof is done for you. So let me explain where this proof came from, all right? And I'm going to kind of mark the proof here. All right. So first of all, it tells us that these two triangles are congruent. So what are the triangles that we have? We have ABD. So we have ABD is congruent to triangle ACD. ACD. So what I'm going to do now is I'm going to make this a little bit bigger just so we can see it a little better here. I'm going to make this a little bigger, and let's mark this picture here. So if we know that these are congruent, and so I'm going to show you how to mark pictures congruent. So let's mark all the corresponding angles that are congruent. So I know that if this is true, angle B corresponds with angle C. So I'm going to put one arc there. Angle BAD, this angle right here, corresponds with CAD, this here. So I'm going to put 2 arcs. And I know that angle BDA, I'm going to put 3 here, is congruent to angle CDA. So I'm going to put 3 here. It's going to get a little busy here for a second. Now let me switch the colors. Now let's talk sides. Well, what are the corresponding sides? Well, BA, okay, and I can see it here in the writing. BA is congruent to AC. See that, how it's written? So I'm going to put a 1 congruent slash through here. All right. I also know that BD, you can see it in the writing here, BD is congruent to CD. So BD, I'm going to put 2 slashes to show this is congruent to this one. And then obviously the middle one is congruent to itself, so I'm just going to put 3 there. All right, and that's a way you can mark things to show they're congruent, because I'm a visual learner. I need to see the pictures. Okay, so why are these two triangles congruent? Why do we know they're congruent? That's given to us, right? That's like an early birthday present or whatever, a late birthday present. Givens are good old-fashioned reasons, though, okay? There's nothing wrong with the good old-fashioned given. You have to be given some sort of information to go anywhere. If you're not given information, you can't go anywhere. All right. Now, why do we know that BD is congruent to CD? Well, that's because of CPCTC, right? This is a CPCTC step. They're corresponding to each other. BD, let me highlight it. BD right here is congruent to CD. And the reason they're congruent to each other is they're corresponding. And when triangles are congruent, or any figures are congruent, their corresponding parts are congruent. That's the whole CPCTC thing that we talked about at the beginning. Okay, now, what are we trying to prove? We're trying to prove that D is a midpoint of BC. Well, D is a midpoint because that's what the definition of a midpoint is. The definition of a midpoint is a point that creates two congruent segments. It's the point that creates two congruent segments. So that's what a midpoint is. We've defined a midpoint, if we haven't done so far, but I think we have. A midpoint, MP, is a point that creates two, and since we're talking about congruence here, congruent segments. And we did, and we know they're congruent because of CPCTC. Okay? All right, so let's do one more problem here. And, well, I'm going to do that one. Let's do this one right here. This one looks pretty good. All right, so copy this one down, and now we're going to do a proof together. Okay? So notice up here when we did this proof, we have statement, reason. This is called a two-column proof. It's the easiest way to do a proof. So we're going to do a two-column proof on this problem right here. So the first thing we're going to do is we're going to do statement, reason. Okay? Now I'm going to put, so we're going to have a statement, and we're going to have a reason here. Okay. Now the first thing that they tell us is that triangle SVT is congruent to triangle SWT. Okay, now before I go any further, remember we're trying to prove this. We're trying to prove that line ST bisects angle VSW. That's our whole goal here. We're showing that ST is an angle bisector. It bisects the angle. So remember, where is VSW? VSW, this entire angle right here, we're trying to show that this line, this segment right here, I'll make it a little smaller. This segment right here, that green segment, is a bisector of that entire angle. Okay, and what does it mean to bisect? Bisecting means that it's a line that splits an angle into two congruent angles. Okay, so that's what we're getting at here. So let me undo that because I think that could get a little messy. All right, so first of all, let's go back to the beginning statement. Why do we know these two triangles are congruent? Yeah, it's given. That's no big deal, right? It's just given. That's a given statement. Given statements are necessary in geometry. We have to know that's given. So we want to put that into our two-column proof. All right, now, what the next thing I would do is, now remember what we're trying to do. If ST is a bisector of the big angle, then I need to know that this angle right here is congruent to this angle right here. And if they are congruent to each other, then we can say by definition ST is a bisector. So I think we can say that right away. We can say that angle VST is congruent to angle WST. And why is that true? Why do we know those two triangles are congruent to each other? Yeah, that's CPCTC. Corresponding parts of congruent triangles are congruent. These two angles are corresponding to each other, just like these. Let me do this. And there's lots of, remember, there's 6 corresponding parts. So we could say these angles are congruent to each other. We could say these two angles are congruent to each other, and then we can do a bunch of side stuff. Notice we don't need anything about the sides. So we have these 3 pairs of corresponding angles to each other, right? All right. So now we can now say that ST, segment ST, bisects angle VSW. And why can we say that? Why can we say that is true? Well, that's the definition of an angle bisector. This is shorthand for definition. So instead of writing the whole word, most math people just put DEF with a little n, little kind of, and that's just a shorthand notation for definition. Definition of an angle bisector. If a segment is an angle bisector, then it creates two congruent angles. And we know they're congruent because of CPCTC. Sound good? All right, ladies and gentlemen, here's your homework for tonight. One problem, and I want you to give it a try and be ready to show me it tomorrow. So here's the deal. I have a problem here for you right here, and I want you to give this a try. Let me tell you what it is. So copy this down. It says that ABC is congruent to triangle ADC. Okay? So I want to know prove that AC bisects angle BAD and AC bisects angle BCD. And I want you to write that in a proof, in two-column proof, a statement proof, just like we did here. And it's going to be very similar to what we did here. A little bit longer, but not as quite as long. Okay? So this is what I want you to do for tomorrow. And then we will continue this study tomorrow and move on a little actually after that. Okay. Hope everyone has a great weekend this weekend or had a great weekend. And I'm looking forward to seeing you all tomorrow to continue our learning into congruent parts. Okay. See you guys later. Have a great day. Bye.